Hi, I'm Mudinda and I'm here to help you understand maths better for free. Now, grade 11s and 12s, today we're going to be talking about both the hyperbolic and exponential functions. Let's get started on the hyperbolic function. The hyperbola has the following general formula. F of x is equal to a over x minus p plus q. Now, to start us off, you need to note that a hyperbola graph has asymptotes. We know that an asymptote is a line that the graph tends towards. In other words, it tries to reach that line, but it never touches it. The hyperbolic function has two asymptotes. One of them is x is equal to p, and the other one is y is equal to q. Now, weirdly, the vertical asymptote is that x is equal to p1, and the horizontal one is y is equal to q1. That's because a line called x is equal to p is just a vertical line that has the same x value, p. Y is equal to q is a horizontal line that has the same y value, q. And I'll show you that in a second. But remember what we said when we looked at parabolas. Whenever an equation has a minus right next to it, when you extract that thing from the equation, you must flip its sign. So if we had here x minus 3, then the asymptote for x would be x is equal to positive 3. We flip the sign. Another really important thing about the hyperbola is its shape. And its shape depends on the value of this guy, a. If a is positive, then the hyperbola graph will be in the first and third quadrants. If a is negative, it will be in the second and the fourth quadrants. But the interesting thing now that we have introduced asymptotes is that quadrants are actually now determined by the asymptotes, not by the y-axis and the x-axis. In other words, the asymptotes now act as the new x-axis and y-axis. So if one of the asymptotes was this blue one here, x is equal to p, and this other one, y is equal to q, and we were told that a is greater than 0, our graph would look something like this. It would completely ignore the x and the y-axis. Sorry, that's a big mistake. It would look like this. So the asymptotes now act as the new x and y axes. And since a is positive, it would be on the first and the third quadrant. Great. Let's actually talk about axes of symmetry of a hyperbolic function. Now, the axes of symmetry are two lines that symmetrically cut the graph. For example, this line here. This line symmetrically cuts the graph. If you try to fold the page along this line, this piece here would perfectly fit this piece. Of course, we're ignoring the fact that I don't have a very perfect sketch here. And if you cut or folded your page along this line, right, then again, the two pieces would meet symmetrically. We call those two lines the axes of symmetry, and you need to know how to determine them. To determine the axes of symmetry is actually quite straightforward. There's two of them in every hyperbola. One of them is y is equal to x plus c1 with a positive gradient of 1 there. The other one is y is equal to negative x minus c2 with a negative gradient of minus 1 there. And how do we determine c1 and c2? We substitute the point p is to q in order to determine c1 and c2. And we'll see that in an example. Let's look at an example of sketching a hyperbolic. Here, we're asked to sketch f of x is equal to 1 over x minus 2 minus 1. Well, to start us off, what shape should this take? Well, the value of a is 1, meaning that a is greater than 0. So since a is greater than 0, this thing needs to go in the first and the third quadrants. Secondly, it has asymptotes. Asymptotes for a hyperbola is x is equal to p as well as y is equal to q. So in our case, we'd have x is equal to positive 2 since we must flip its sign, and y is equal to negative 1. These are the two asymptotes. Then we can just find the y and x intercepts and sketch. To find y-intercepts, we always let x be 0. And so, in our case, we know y is equal to 1 over x minus 2 minus 1. We, in place of x, put 0. So we have y 1 over 0 minus 2 minus 1, which is negative a half minus 1. Now, negative a half minus 1 gives us negative 3 over 2, or in other words, negative 1 comma 5, which means our y-intercept is an x value of 0 and a y value of negative 1 comma 5. On the other hand, in order to find our x-intercept, we're going to let y be 0. We know that y is always equal to 1 over x minus 2 minus 1, and in place of y we can put 0. Now let's move this 1 to the other side so we can solve for x. We have 1 is equal to 1 over x minus 2. We can cross multiply here. 1 times x minus 2 is x minus 2, and on the other hand 1 times 1 would be 1. And so therefore x is actually 1 plus 2, which means x is 3. And so our x-intercept is an x value of 3 and a y value of 0. There you have it. We've now got the shape, the asymptotes, and both the x and y intercepts. We can actually now sketch this graph. Let's start by drawing our asymptote. Our asymptotes are an x value of 2 that is the vertical asymptotes. So at an x value of 2, you're going to draw a vertical line that runs through the x value 2. Let me make that a bit more accurate. It would look something like this. This is the line that joins all points on the Cartesian plane that have an x value of 2. If you have a point here, the x value is 2. It may have a y value of 3, but the x value is 2. Okay. A point here, the x value is still 2. It may have a y value of maybe negative 1 comma 5, but the x value is still 2. And that's why we say a vertical line running through the x value 2 represents x is equal to 2. It collects all the points on the Cartesian plane that have an x value of 2. The other asymptote is y is equal to minus 1. At a y value of minus 1, we will draw a horizontal line. That's the line that collects all the points that have a y value of negative 1. Now the y-intercept is at negative 1 comma 5. So this graph cuts the y-axis at negative 1 comma 5. That's right here, between negative 1 and negative 2. We have an x-intercept at 3, meaning the graph touches the x-axis at 3. Now since we know that this is the shape this should take on, we can go ahead and draw this to look something like this, making sure that it tends towards the asymptote but never touches it, and it passes through the x-intercept. Same thing on this side. The graph must tend towards the asymptotes, never touch them, and it must pass through its y-intercept of negative 1 comma 5. Now very importantly, grade 11s and matriculants, we said you must indicate those points. 3 is to 0, 0 is to negative 1 comma 5. And there you have it. That's how you would sketch a hyperbolic function. Now, how would we find axes of symmetry? Let's look at an example for that. Here, we're asked to determine the axis of symmetry for f of x is equal to 2 over x minus 4 plus 1. Just a bit of a refresher, how do we find those? Well, there's two magic formulas. Y is equal to x plus c1, and y is equal to negative x minus c2. And we substitute the point p is to q to determine what c1 and c2 are. So here we would say, well, the first one is y is equal to x plus c1, and we want to substitute the point p. What's the value of p? Positive 4, we flip its sign, and positive 1, p is to q. So now in place of y I'll put 1, in place of x I'll put 4. This is what we call to substitute a point. To solve for c, I'll move 1 to the other side, so c1 is therefore actually negative 3. So one of the asymptotes is y is equal to x minus 3, since c1 is negative 3. The other axis of symmetry is y is equal to negative x minus c2. Again, in order to find c2, we're going to substitute the point p is to q, just 4 is to 1. In place of y, we put 4. We put 1, and in place of x, we put 4. So we have 1 is equal to negative 4 minus c2, and solving for c2, we move 4 to the other side, would find that therefore c2 is actually just 5. So the other axis of symmetry is y is equal to negative x plus 5. We're just replacing c2 with 5. But here, we just replaced c1 with minus 3. And that is how you find the axes of symmetry. Now, let's talk about the exponential function. In my experience, a lot of learners hate the exponential function. I'm not so sure why, but I think it has to do with its shape. Now, let's talk about it. The exponential function is in the form f of x is equal to a times b to the power of x minus p plus q. This graph also has an asymptote, but just one. Y is equal to q, the horizontal asymptote. Please note, yes, there's a p there. It is not an asymptote. Now, the shape depends heavily on a and b. Let me fix this part of the notes quickly. And by the way, I will attach the notes below and you can follow along. A can either be greater than 0 or less than 0. B can either be bigger than 1 or between 0 and 1, in other words, a fraction. It is the different combinations of a and b that determine the shape that your exponential function will take. Here's the cheat sheet. If a is greater than 0 and b is greater than 1, your graph's shape will be like this. Okay? If a is bigger than 0 but b is a fraction, it's between 0 and 1, your graph looks like this. It's almost like this graph, except in the other direction. If a is less than 0, but b is bigger than 1, the graph looks something like this. To me, it actually looks like this graph flipped. On the other hand, if a is less than 0 and b is a fraction, b is between 0 and 1, your graph looks something like this. These 4 shapes you have to commit to memory. Luckily for now, you can download these notes and give it some memorization. But these are the different shapes that your exponential function could take on. And so the very first thing you need to determine is a bigger than 0 or less than 0? Is b bigger than 1 or is it a fraction? Is it between 0 and 1? Now, let's look at an example. We're being asked here to sketch f of x is equal to 2 times a half to the power of x plus 1 minus 4. To start us off, this graph would have an asymptote. Sorry, asymptote actually has one s, I think. It would have an asymptote at y is equal to q, and in our case, q is minus 4. What about its shape? And I really do suggest that you actually give yourself little headings when you're answering in your exam. It also helps the examiner just to clearly see what you're doing. The shape depends on a and b. Is a greater than 0? Yes. What about b? Is b bigger than 1 or is it a fraction? It's a fraction. B is between 0 and 1. Then we need to decide which shape does this take on. We can use our cheat sheet. A bigger than 0, b a fraction. A bigger than 0, b a fraction should take this shape. So this graph needs to look something like that. Great, we've got a little shape sketch down. Now let's find the y-intercept and the x-intercept. To find the y-intercept, we're going to let x be 0. Now in our case, y is always equal to 2 times a half to the power of x plus 1 minus 4. In place of x, if we put 0 here, we're left with just 1. What is 2 times a half? That's 1. So now we have 1 minus 4. And we know that 1 minus 4, or is it 1? Yes, 1 minus 4 is a negative 3. And so our y-intercept is an x value of 0 and a y value of minus 3. We can find our x-intercept by letting y be 0. Now, y is equal to 2 times a half to the power of x plus 1 minus 4. In place of y, we should put 0. So we have 0 is equal to 2 times a half to the power of x plus 1 minus 4. If we move 4 to the other side, we have 4 is equal to 2 times a half to the power of x plus 1. If we divide both sides here by 2, we then therefore get that 2 is equal to a half to the power of x plus 1. Now, here's a nice funky way to solve this. I know that a half is 2 to the power of minus 1. Now, I know that if I have a to the m and it's raised to the n, it must become a to the m times n. So since I have 2 to the minus 1 raised to the x plus 1, minus 1 must multiply this. Which means I can here now end up with 2 is equal to 2 to the power of negative x minus 1. So if 2 to the 1 is equal to 2 to the negative x minus 1, that means negative x minus 1 is equal to 1. We can drop the bases. So negative x is equal to 1 plus 1. Negative x is equal to 2. And so x is therefore equal to minus 2. And so our x-intercept is at minus 2 and 0. We can go ahead and sketch our graph. Let's start off with our asymptote. The asymptote is at a y value of minus 4. Like I said, we only have here a horizontal asymptote at y is equal to q. Our y-intercept, the graph cuts the y-axis at minus 3. The graph cuts the x-axis at minus 2. We know the shape should look something like this, and so we can see that we can replicate that by just joining these points to do something like that. It's very important that we show this is negative 2 to 0, and that this is 0 to minus 3. And there you have it. You've now sketched your exponential function. I hope this lesson was helpful, and I'll see you guys in the next video where we're going to be talking about graph interpretation. We will be translating maths language to simple plain English for functions. We will be looking at those complicated sounding questions like, for what values of x is f of x greater than 0? Or for what values of x is f of x increasing? We'll be looking at how to understand each of those questions and how to answer them.